This is a question from discrete mathematics. So we are given 4 options and we are asked to find out which are the tautology among them, and 4 options are given. So first let's try to see how to solve it. All these options are of the form P implies Q. So first let's draw the truth table of P implies Q. So P implies Q has a truth table that is like this: P, Q, P implies Q. So if both are true, it is true. If P is true and Q is false, then it is false. If both are, if P is false and Q is, assuming P is false and Q is true, then it is true. Then if both are false, then it is also true. This is the basic truth table. Now let's see how to solve it. So first we will see how to eliminate the options. So A and B seems to be okay because only assume this as the LHS part, and if you are assuming this is the RHS part here and same here, this is LHS and this is RHS, then both are having two variables only. But here if you see this as the LHS and this as the RHS, here we are introducing a new variable R. So this R can take any value. So the tautology can be coming true in 3 cases. This is true true or false false, that is 2 cases, and this can be false and true, then also it is true. If it is true or false, then it is false. So for it to be tautology, it has to be true in all the cases. But since we are introducing a new variable R, we cannot arrive at that conclusion. So this statement seems to be false. Similarly, here also, we are introducing a new variable R here, which is not present in this. So the same case that we applied for C, option C applies here also. So these two options are wrong. So C and D only are eliminated. Now we'll see how to get the correct answers from A and B. So first of all, P implies P and Q implies P implies Q. So if you are able to get the LHS part as same as RHS part, means both are same only, then it can have same values only, that is true true or false false. Then in that case this comes to be a tautology. Now let's see how to solve it. So there are two important formulas that we need to remember. P implies Q means negation P or Q. This is the first formula. Then OR can be represented using plus and AND can be represented using dot. Now let's see how to solve it. So this follows P implies Q. P implies Q means negation P or Q, that is P bar plus this is P and Q, that is PQ. Now by distributive law, we can write it as P bar plus P into P bar plus Q. So this is 1 plus 0. It has P bar plus P turns out to be 1 into P bar plus Q, that is P bar plus Q. This means this is equal to P implies Q, which means P implies Q. So this turns out to be, this LHS turns out to be P implies Q implies P implies Q. So whatever value of P and Q happens is being taken here, that only it will be taken here also. So this can be true, then this becomes true. It can be false, then it becomes false. So in both cases, this statement turns out to be true. So this is a tautology. So this can be a correct option. Now let's see the second question. Second option is P implies Q, the whole implies P or Q. So this can be broken down to negation P or Q, and then this is the LHS part. This can be again broken down to P bar plus Q, that is negation P or Q. Now applying De Morgan's law, it becomes P double bar, that is plus Q bar plus this becomes dot or AND operation happens plus Q. There's a law that A plus A bar B equal to A plus B. Now this is A, this becomes A bar and this becomes B. So this essentially turns out to be P into Q bar plus Q. So this becomes P plus Q. So LHS is P or Q implies RHS is also P or Q. So the same rule that we applied for making a tautology is applicable here also. So both A and B are correct. So from the options, option C, A and B only is the correct answer here.